Now we are going to discuss a program that is called the binary search. We have seen the linear search. Right now we are going to discuss about the binary search. The work of both the concept are same. Accept a number from the user and search that particular number in the list and display it is present or not. Fine. But in the linear search, what happens? It accepts the numbers from the user, number or character, any value, and then it will start searching one by one. Suppose it has accepted a number, it will search in the zero position of this list, then it will go over here, then it will go over here, like that way. Okay. It will go on. When it will stop, when it will found the number or the element in that particular list is matched, or the list has been finished and it will stop and display the it is not found. Fine. But in the binary search, what happens? We are going to follow a particular technique, and there is some prerequisite for the binary search. Prerequisite means that things should be previously it should be arranged. First prerequisite is binary search. In binary search, the list will be either in the ascending order or in the descending order. What it will going to be happen? Either it will be in the ascending order or it will be in the descending order. Otherwise, the binary search technique is not going to be work over there. Fine. Now we will discuss about the other things. We know that one, it should be in the either in the ascending order or in the descending order. Now fine, I have used two lists over here. Why? Because see that one, the first one where I am moving the mouse, this what is the size of that particular list? Size is 1 2 3 4 5 6, means in the even dimension. Now if I told you to find the midpoint of the list, formula is size divided by 2. Fine. Size divided by 2, 6 divided by 2, 3. Now this one. Now actually it is the midpoint. See that one. Midpoint means a particular place. Before that there will be same number of subscript, and after that same number of subscript. Means suppose if 3 is the index 3 is the midpoint, means before 3 there will be 2 subscript and after 3 there will be 2 subscript. Now here it has been done, no? See this one, before 3 1 2 3 subscripts and after 3 there is 2. Now we will say I'll put it over here in the 2. Same problem is going to be arise over there. So to find a midpoint, because this is also one of the most important concept of the binary search, you have to find the midpoint. For finding the midpoint, you have to take the list in the odd dimension. See this one. This is 1 2 3 4 5. Now the 2, what will come out? 2.5. But we will follow the integer division. If we do the integer division, it will be 2. There will be no 2.5. 5 will be raised to. See this one. So what we will do? Formula is size divided by 2. The second list which is used, we are using over here, the size is 5. Divide by 2, 2.5 came out. Now we are going to do the integer division. For that 5 will not be there, result will be 2. See this one, if you take the 2, it is a perfect midpoint of the list. Before the 2 there will be 2 subscript or index, after the 2 there is 2 subscript or index. Fine. An array is arranged in a, suppose this array is arranged in a ascending order. Now what I will do, the main technique of the binary search is that I will accept the element from the user, number, character, whatever may be, and after that I will find the midpoint. Okay, the subscript number of midpoint of the list. Now I will match that particular number with the element that has been stored in the midpoint, means in the 2. If the dimension is different, it will be the different one. What has been stored in the subscript 2, 7 subscript, I am going to match that element. If that particular element is greater than the middle element, then I am not going to search in this portion. I am going to search over here. Means my search will start from mid plus 1. Why mid plus 1? Because my list has been arranged in ascending order. So if it is greater than mid, the element that has been made, there is no chance that element has been found over here. So I am going to start from here. And if the element is less than mid, then I am going to search it over here. So we have understood this one. It is an ascending order. If it is in ascending order, if it is the bigger than the middle element, the element that has to be searched, then no need to search over here. If you start the search from the mid plus 1. And if it is less than the middle element, then search over here. Means we are not going to search throughout the array as like the linear search. Now what is the benefit of this one? Benefit is that if the list is big one and it is a big list, the search will perform little bit faster, because we are not going to search throughout the list. We are going to search only a particular portion of the list depending upon the condition. Now we are going to discuss the code. In the code, what I have done, I have declared a blank list L1 where I am going to accept the input from the user, the elements of the list. Size, one variable where I am going to accept the size from the user. Element, this variable has been used for taking the input in the list. Now size is equal to, we have taken that particular whatever the size user is going to be given, but we have to keep in mind that particular thing. If it is an odd dimension, then we are going to find the exact middle point. Now the mid is equal to size integer division, this is a sign of the integer division 2, f and p. Why I am going to use the f and p, that I am going to tell you afterwards. Now this portion I am not going to discuss with you, because this is the portion through which we are going to take the input in the list. We have the in each and every program this portion has been discussed, so I am not going to discuss this one, because each and every program, everywhere this portion is there. Through this portion, this code, we are going to take the input in the list. Now what happens? Now come over here. I am accepting the number from the user which is going to be searched. What I have done, I have accepting the number from the user which is going to be searched into the list. Now come over here. Generally we have seen if inside the for, but here I have written for inside the if. No problem will be there. It looks like a little bit odd, but everything will be fine. Now, so what will we have to do? If num means the number that has been given by the user is greater than L1 of mid. I told you earlier only. If the number that has been given by the user is greater than the element that has been stored in the mid subscript middle, then what I will do? For j in range, I will start the search from mid plus 1. Means if the mid is 2, I am going to start from 3. Fine, because we know that one, the element is greater than mid. So we will start from the, if in the second subscript the middle element is stored, then we are going to start from the subscript number 3. Up to the size it will go on. Fine. Now if it has been matched, F is equal to 1, P is equal to J. Now, this value, I have fixed this value to 0. I have changed this one. Why? I am telling you. And J is the index. I have passed this one to the P. Means when I am going to display the final result, I am going to display that one, the element has been found, and in this index. For that, I have passed that index number to the P. Now, if number is less than the mid element, what will going to happen? I will start search from 0 to mid. From where I am going to search? I am going to search from 0 to mid. I don't have to go after the mid. We know that one. If the element has been found, element found means F is equal to 1 and P is equal to J. Why I have used P is equal to J already I have told you. But what is the use of the F? I have set the value F is equal to 0. If it is found only, then the value is going to be changed to 1. Because, see this one, suppose, take this one only. Suppose the element has been stored, the middle point is 2, second subscript, then 0, 1, 2. Suppose in the second subscript the element has been stored over there, the particular element, the number which is given by the user. Now first what will happen? It will match the number with the element that has been stored in the 0 subscript. And if I write this one, then directly I have to write if now is equal to L1 I found else not found. In this case, what will going to be happen? If I do not use the F1, then I have to do like that. 0 subscript it is not found. It will show not found. In the first subscript it is not found. It will show you not found. And ultimately it will going to be show you the found. To avoid this one, I have done this one. What I have done ultimately, I change the value. If it is found, it will be changed to 1. If it is not, it will remain as 0. Now at last I write if f1 is equal to 1. If it is found anywhere, obviously the value of the f will be 1, and write found else not found. Thank you.